Young Earth creationism is precluded entirely by dozens upon dozens of well-known facts of the natural world, from the radioactive decay law, the speed of light, and the nature of the geologic column, to the statistics that surround common ancestry, the fossil record, and our genetic relationship to the rest of the primates, mammals, and really just the entire tree of life. But so frequently I encounter what I am calling bite-sized busts, aspects of STEM fields that entirely preclude young Earth creationism that aren't typically talked about, but bust hard nevertheless. Be it geology, anthropology, astronomy, or physics, here we discuss the minutia of fields that leave young Earth creationism out in the cold. If you're new to the channel, don't forget to subscribe if you like this kind of content, leave a like and maybe a comment, and if you feel like supporting the channel in other ways, you can check out my Patreon, my PayPal, or stores. Today we are discussing one of the most famous supports for human evolution, the fusion of Human Chromosome 2. And of course we will discuss how this tiny section of the genome creates big problems for young Earth creationism. Come to think of it, this one actually gets the old Earth creationists and the ID proponents too. As always with bite-sized busts, we will look at the data, explain why it's problematic for young Earth creationism or creationism in general, look at their responses to this problematic issue, if their responses do indeed exist, explain why those responses don't make the problem go away, and finally, we will try to predict how these creationists will continue to grapple with the issue in the future. This video actually serves as something of a remake of a video I made several years ago, but I wanted to clean it up with better audio and present the argument in a more streamlined way. So what's the deal with Human Chromosome 2? And how exactly does it support human evolution? Chromosomes are bundles of genetic material that contain the instructions to make organisms and keep them running. They are typically discussed in their overall number, in their paired number, and creatures across the kingdoms of life vary wildly in the number of chromosomes that they have. Our superfamily of Hominoidea is no exception. The Hylobatids, or gibbons, range from 38 to 52 chromosomes, while the hominids have a tighter spread of 46 to 48 chromosomes. Within the hominids, humans stand out as the only great ape with 46 chromosomes, while panins, gorillans, and pongins all have 48. Well, okay then. Evolutionary theory makes a very simple prediction with this. If all the great apes share a common ancestor, then the common ancestor of all of these great apes either had 46 chromosomes, and the great apes excluding humans experienced some kind of fission event going from 46 to 48, or the common ancestor of all the hominids had 48 chromosomes, and just humans experienced a fusion event. Obviously, this latter fusion is the more parsimonious hypothesis because it requires fewer steps. One fusion event occurring in one lineage, or 3 fission events occurring independently in the same place at the same time in 3 lineages. Obviously, one of these makes more sense. So it really is this simple. Human evolution predicts a fusion event that happened sometime in the past 7 million years, whereby 2 ancient ape chromosomes fused into a single chromosome. Since we get chromosomes from both parents, this would reduce the total number of chromosomes from 48 to 46. If humans and the other apes share a common ancestor then, we should be able to find this fusion site in the genome of humans, like a smoking gun. When chromosome numbers were first available for both humans and chimps, Human Chromosome 2 was singled out as this potential fusion due to the similarity it had to chimpanzee chromosomes 12 and 13. This is called homology. But absolutely critical to science is the presence of a real bona fide prediction of something before the discovery of that thing. Young Earth creationists do not seem to understand this and constantly and consistently confuse accommodation of data for prediction of that data. So I wanted to suss out the very first real prediction of the fusion of Human Chromosome 2 for you fine apes. And it took me a while. In 1956, the chromosome number for humans was officially published. It noted that it was very unexpected indeed that humans would have 46 chromosomes, but no speculation on the reason for this. Then, in 1960, the chimpanzee chromosome number was officially published. This time, they did not appear to be surprised, although again, they chose not to speculate on the reason for the human-chimp difference. After this paper, I found a 1973 paper that disagrees with the notion of a fusion, at least with the present evidence. And this paper gave me the key to finding the first prediction by name-dropping Truelot and Grouchy. So I followed the lead to the original paper, and the paper was in French. And also in a book that is seemingly unavailable online. But I couldn't just give up. And so I then found a subsequent paper by the same authors from 1973 that was in both German and English, where they referenced their original prediction, but I still wanted the real thing. And so I journeyed into the darkest corners of the internet to bring you a translated screen grab of the original book, Comparative Karyotypes of Primates, found in Truelot and Grouchy's chapter, Karyotypes of Man and the Chimpanzee, Comparison of the Topography of Bands, Possible Evolutive Mechanisms. To my knowledge, this is the first prediction of the Human Chromosome 2 fusion event, all the way back in 1972. So with the prediction set, what kind of evidence would we need to see to support it? Chromosomes are structured in an orderly way. They look like X's and contain a centromere at the center of the X with telomeres on the tips of each arm. The centromeres and telomeres are identifiable by repeated sequences only found in such densities at these locations. The purpose of the telomeric sequences is to protect the genetic material, and the purpose of the centromeres is to bind chromosomal pairs during cell division. So then, if two ancient ape chromosomes fuse to create human chromosome 2, then we should find the remains of telomeres in the middle of the chromosome where the fusion occurred, and a second cryptic centromere somewhere else in the chromosome. Simple. The first breakthrough occurred in 1982 with The Origin of Man, a Chromosomal Pictorial Legacy. This paper compared high-resolution karyotypes of humans, chimps, gorillas, and orangutans and noted that 18 of the 23 human pairs were virtually identical to the other apes. The other chromosomes showed only slightly different banding. The pictures that came out of this study were bone-chilling to YECs as they displayed the similarity of humans to the other apes in all glorious illustration. However, creationists could still claim common design. Just because human chromosome 2 looks virtually identical to a stacked chimpanzee chromosome 12 and 13 doesn't mean that a fusion necessarily occurred. God could have just done it that way. So we needed the actual genetic sequences in support of a fusion event in order to make this case unbreakable. Unfortunately for the creationists, the human genome would be sequenced in 2001 and the chimpanzee genome in 2005. And so the smoking gun was uncovered in its full glory by Hillier et al. In 2005. The precise fusion site was identified with the telomeric remains in the middle of the chromosome as expected and the vestiges of a second cryptic centromere as well. Further exploration was carried out in 2012 where the steps of the fusion are outlined on the basis of the characteristics of the fusion site. So here we have a stunning confirmation of evolutionary theory, specifically human evolution, that came after a prediction over 25 years earlier. So the case simply must be closed, right?
Wrong!
In conventional science, the case is closed. You couldn't ask for a clearer depiction of the fusion of human chromosome 2. But in the wacky and wild world of Young Earth Creationism, they're still floundering about with this one. Young Earth Creationism requires a spontaneous creation event some 6,000 years ago, as well as a global flood event some 4,400 years ago that is responsible for all layers of the geologic column from the Cambrian to the Cretaceous, as well as their fossils, every impact event or mass extinction signature within said layers, the current positioning of the continents, the state of decay of all radioactive elements, and finally, the various levels of diversity for all extant life. Creationists typically believe that humans are a special creation set apart from all other animals, and this means that they simply cannot have evolved from a more basal ape, nor can they be related to any of the other apes at all. Thus, the fusion is a problem. I should specify, it's a problem for most of them. As always, there are your more level-headed creationists like Kurt Wise and the folks at Reasons to Believe, who basically just kind of shrug and go, yeah, it's pretty clear that there was a fusion event. I guess God just made Adam and Eve with 48 chromosomes, and then a fusion happened sometime after the fall. What are you gonna do? Others, like Answers in Genesis and its acolytes, rage against the idea. So how exactly do these particular young Earth creationists attempt to refute such a clear-cut case? Let's dive in. Young Earth creationists thankfully provide a very simple series of arguments against the fusion event. Number one, they argue there is a functional gene on the fusion site. Thus, it cannot be a fusion site because the gene could not function split between the two initial chromosomes. Two, they propose that telomere-telomere fusions cannot happen. They argue that we haven't seen this type of fusion event that would be required for the human chromosome 2 to fuse. 3, the site is degenerate. If it were a fusion site, it should not be degenerate. 4, human chromosomes lack the characteristic ape satellite DNA. And finally 5, we find the telomere and centromere calling cards elsewhere in the genome, so using them as evidence for the fusion is faulty reasoning. There is a final argument that creationists making the case for these 5 previous things will throw at you, and usually they'll only throw it at you after you have thoroughly eviscerated those 5 arguments, as we are about to do here, and that is they resort to Kurt Wisen reasons to believe, well, I guess God could have just done it that way. And at that point, you can rest easy knowing that it's a fusion site. But this is where that distinction that I made earlier comes in, because evolutionary theory predicted the fusion event, and creationism is simply accommodating it. As it turns out, most of these arguments are made by one guy, and it's Jeffrey Tompkins. You may remember him as the creationist that proposes that humans and chimpanzees are actually only 84% similar, a number that he improperly gleans by not weighting the sequences when comparing the 2 genomes, and also a process that ends up getting humans and humans being only 87% similar to each other. Surprise, surprise, he also thinks that the human chromosome 2 fusion is bunk, so we will be primarily dealing with work put out by him. Let's start with number 1. Is there really a functional gene spanning the fusion site?
No.
The gene that they are referring to is called DDX11L2 regulatory RNA helicase, and it is unsurprisingly a part of the DDX11L2 family of genes. This gene is non-coding and is not considered to be functional, and in fact is commonly indistinguishable from genetic noise when sequenced. This is why it is actually considered to be a pseudogene, an imperfect copy of a functional gene. The reason why creationists like Jeffrey Tompkins propose it is functional is because it meets the bare minimum requirements of the title under the most liberal usage. It is expressed. But I wanted to be sure, so I reached out to Ken Miller, a PhD biologist, former Harvard professor, and key witness in the Kitzmiller versus Dover trial. He kindly explained that the pseudogene has no currently known function and also doesn't typically span the fusion site, most commonly being off to one side. But most importantly, the family of genes that DDX11L2 belongs to, the DDX11L family, has every other member being adjacent to a telomere. This means that Tompkins has inadvertently aided in making the case for the fusion site, given his work showed that a telomere-specific pseudogene, DDX11L2, is found in the middle of only one chromosome, and it's human chromosome 2 at the proposed telomere-telomere fusion site. Oopsie. Number 2 argues that telomere-telomere fusion events do not happen.
Oh, that's sus!
That's sus!
This is falsified by a simple literature search, which shows that it does actually happen, and in pigs and horses, it's happened somewhat recently. As a side note, not knowing this got intelligent design advocate Casey Luskin in some hot water as he was mortally embarrassed for not knowing the literature by Dr. Eugenie Scott. He was very bashful about this later on. Number 3 suggests that the degenerate nature of the fusion site means it probably isn't a fusion site at all.
Are you joking?
Interestingly, but not surprisingly, this is a straw man argument coming from Jeffrey Tompkins. It effectively sets it up as though the conventional view expected the site not to be degenerate, when in fact, the opposite is the case. It couldn't be a fusion site if the site wasn't degenerate, and this has been known for quite some time. Allow me to explain. Remember that chromosomes are capped with telomeres, and the purpose of these telomeres is to protect the chromosome from degradation during replication and to prevent fusion with neighboring chromosomes. These regions are themselves buffered by subtelomeric regions, which look like telomeres sequentially, although they are degraded in comparison. It is in these subtelomeric regions that we tend to find the members of the DDX11L family. What this means is that in order for a fusion event to occur, the intact telomeres must be absent or have failed, leaving the degenerate subtelomeric regions open to fusion, meaning that what we see is what we expected to see. This degeneration may be exacerbated by the fact that tandem repeats are typically unstable. Either Jeff Tompkins didn't know this and he's a bad geneticist, or he did know this, and he left it out. How curious. Number 4 argues that we should see ape satellite DNA if the human chromosome 2 is the result of a combination of 2 ancient ape chromosomes. Tompkins and many other young Earth creationists propose that we simply do not see such satellite DNA.
How?
They're wrong. We do. In a 2019 paper, it showed that the majority of satellite DNA is shared among all hominids, so humans, chimps, gorillas, and orangutans, and that the satellite DNA that is not shared is species specific. This is obviously pretty problematic for the young Earth creationist kinds, as it means that this DNA has chimps and bonobos being uniquely created groups. Finally, there is number 5, where creationists argue that we find the telomere and centromere calling cards elsewhere in the genome, so using them as evidence for fusion is faulty reasoning. Our DNA is made of 4 base pairs: adenine, thymine, guanine, and cytosine, and these guys are abbreviated as A's, T's, G's, and C's. Telomeres and centromeres both have respective calling cards, which are sequences of these base pairs that always occur in a specific order at the telomere and centromere sites. Critically, they're not just found there once, but they're found there in high densities, so the calling card sequence is found over and over and over and over again at telomere and centromere locations. The telomere calling card is TTAGGG in forward, and its reverse complement is CCCTAA. The centromere calling card is this thing. We'll just refer to it as an alphoid repeat. The most obvious support for human chromosome 2 is the fact that we find the telomere calling cards in the middle of human chromosome 2 at the purported fusion site. We also find the centromere calling cards twice in human chromosome 2. One for the main centromere, and once more for the cryptic centromere, the centromere of one of the original chromosomes. The Tompkins argument is that we can't utilize those as calling cards because we find them elsewhere in the chromosomes, meaning that they aren't exclusively linked to telomeres and centromeres. Fortunately, Tompkins' argument is pretty easy to test. We simply need to run the human genome through a tool like BLAST and see whether or not the calling cards that consistently denote telomeres and centromeres in normal context can be found at the fusion site and the cryptic centromere in human chromosome 2, or whether they can't consistently be used as calling cards because they are scattered throughout the genome in non-relevant locations. Fortunately, Evograd, a friend of the channel, has already done this and provided me with the data, so let's take a look. We'll start out with telomeric repeats. Evograd lays it out quite plainly. The claim is that as a result of the fusion site that produced human chromosome 2, there exists a fusion site that consists of head-to-head telomeric repeats on chromosome 2. So the telomeric calling card sequence running in forward and running in backward, as these 2 telomeres in the ancient ape genome fuse together. We'll start out with telomeric repeats. Evograd lays it out quite plainly. The claim is that as a result of the fusion site that produced human chromosome 2, there exists a fusion site that consists of head-to-head telomeric repeats on chromosome 2. So that's that calling card sequence that runs forward and backward. If we find these calling cards in high density running in forward and backward, it is indicative of a telomere-telomere fusion site. The creationist counterclaim, as listed by Evograd, is that the telomeric repeats are found all over the genome. And so there's nothing special about the site claimed by evolutionists to be the fusion site. Thus, the fusion never happened. The cool thing about Evograd's work here is that he lays it out in such a way that any of you out there can test this for yourself. To test this, he uses a program like BLAST, and the evolutionist prediction is very simple indeed. We should find a head-to-head arrangement of telomeric repeats in the purported fusion site that is extremely rare or unique. Creationists, on the other hand, would suggest that we would find these blocks of head-to-head telomeric repeats found all over the genome, not just at the fusion site. The telomeric repeats, to remind you, are TTA, GGG in forward with CCC, TAA in reverse. Remember, those calling cards are what denote telomeres. And this is the purported fusion site. We see the calling card in forward in red and in reverse in blue. And it's over and over and over again in an extremely high density, in the center of human chromosome 2, suggesting a fusion. But the creationists argue that instead of a fusion, this is just indicative of a high density of a regular old sequence that can be found elsewhere in the genome. So let's test that. All you gotta do is search the human genome for a 300 base pair sequence that comprises the forward and backward telomeric repeats and see if we can find it elsewhere. EvoGrad gives you instructions for how to do this for yourself, so you can pause if you'd like to run it. And the output should look something like this. 5,000 hits showing locations on the chromosomes where the hits are. He notes there are hits all over the genome, so are the creationists right? And then he says no, because if you look at the table of hits, there's only one location in the entire genome that spans the entire query sequence, that is to say, the full density that encompasses the entire head-to-head arrangement, and it is the fusion site. In greater detail, you can see that the other hits comprise only half of the query, around 150 base pairs, and these are the normal telomeres, either in forward or in reverse. Only the fusion site hits the entire query. So with regard to telomeres, Tompkins is just blatantly wrong. There is only one place on the entire human genome, as you can check for yourself and as Tompkins could have checked for himself, where we find the entire head-to-head telomere fusion site with the telomere calling cards in forward and in reverse. EvoGrad did the same thing with alphoid repeats. He notes that the consensus is this wacky thing right here, and we can, just like with the telomere calling cards, search the human genome for this sequence in repetition. This is because, like previously mentioned, if you have two chromosomes that fuse together, you should have telomeres in the middle, and you should have two centromeres, a primary centromere and a cryptic centromere that's basically been relegated to having no job at all. Don't be intimidated by the Excel spreadsheet, it's actually very easy to understand. The important columns for our purposes is the chromosome column, the number of repeats column, the distance between the block and the centromere column, the length column, and the density of repeats in the block column. The cryptic centromere, if it exists, should stick out in two primary ways. One, it should have a high density of alphoid repeats, and two, these alphoid repeats in their high density should be far away from the primary centromere. This is because centromeres have what's called an extended region, which is exactly what it sounds like. It's just an area around the centromere that still has alphoid repeats. But if the fusion event did indeed occur, then the cryptic centromere should be very far away from the main centromere due to the fact that they have original locations prior to the fusion that are separated by vast amounts of genetic material and the telomeres. So what does the data actually tell us? Let's take a look. In chromosome 1, we see our centromere is here in yellow with no repeats outside of it. Chromosome 2, there's our centromere, and located a vast distance away from it, here's our cryptic centromere with 185 repeats, located nowhere near the centromere or the centromere's extended region. It is the furthest away from the centromere that any alphoid repeat blocks are found. But let's look at the other chromosomes because there's something interesting going on with chromosome 9. Chromosome 3, there's our centromere. 4, there's the centromere. 5, there's the centromere. In 6, we have another cluster of alphoid repeats, but they are within the extended region, so there's nothing really to see here. Same with 7, same with 8. Chromosome 9, however, has its centromere located at this spot, and far away from it, but nowhere near as far as the cryptic centromere, we see a high density of alphoid repeats. This has to do with heterochromatin, and we'll talk about it in a second. But the remainder of the chromosomes has the same exact situation. Either a single density at the centromere or a density at the centromere and in the extended centromeric region. Once again, this can be done by anybody at home if they want to take a look at it, and we even have our centromeres in X and Y here at the bottom. It turns out chromosome 9 is chock full of heterochromatin, and it appears to have a second extended block of repeats. It's known for being structurally polymorphic, as noted by Humphrey et al. In 2004, and Evograd notes that it's clearly a unique case, as it's very different to the block of alphawood repeats that are found on chromosome 2. He notes, however, that even if it weren't, the alphawood blocks that we find in human chromosome 2 that represent the cryptic centromere are the furthest away from the regular centromere and still best fit the cryptic centromere diagnostic characteristics. So how exactly do young Earth creationists deal with all of this? Well, they mostly don't. They tend to double down on the "it's still not a fusion site" without elaboration, or they say, "so what if it is? That doesn't prove evolution." Now, I did see a newer paper in 2017 from Tompkins, and I asked Ken Miller about it just to pick his brain. This time, Tompkins is effectively arguing that there is a functional gene on the cryptic centromere, so it can't be a cryptic centromere. And Ken helpfully pointed out that that can just happen. The centromere is no longer functional in its cryptic sense. The other centromere is what's functioning as the actual centromere for human chromosome 2. So it's perfectly fine to suggest that a gene migrated on top of the cryptic centromere after the fusion occurred. More importantly, however, it's also a pseudogene, just like the DDX11L2. Ken went on to point out that he published a book called The Human Instinct that contained an overly gratuitous explanation of human chromosome 2 going down into the various individual genes, and that this was released in 2018, and he has not heard from Tompkins since then. And they used to email one another, so I find that quite significant indeed. It's also notable that The Human Instinct came out and there has been no professional work on human chromosome 2 by Jeffrey Tompkins since. So it seems indeed that human chromosome 2 is fairly problematic for young Earth creationists, old Earth creationists, and ID proponents alike, at least in the sense that it unites humans with the rest of the hominid family, and it provides an excellent example of an evolutionary prediction come to fruition. I hope that you'll join me next time for another bite-sized bust to some big pseudoscience.